All right. New day. All right. Time to start off the next set of Microsoft prep. Got my interview coming up this. Hey, good to see you, man. Yeah, I took a bit of a break over the weekend. It's been very busy. But yeah, the interview is coming up this Thursday, so I got today, tomorrow to just kind of get myself back into the groove of things. Microsoft, I think, is labeled as easier than Google interviews, and I think doing as well as I did for Google, I should be okay with Microsoft. I'll just have to review a bit more tree, a bit more graph tomorrow, probably. So today I'm probably going to end up doing just a general session. Tomorrow, probably more targeted individual questions, maybe do some on my own time as well, just to make sure that I'm ready for it. All right, let's see what we got. Should be pretty good, should be, I mean, these are all Microsoft tagged, so I'm hoping they're not too difficult, but also not like, you know, is palindrome. Kind of excited. I got my last quarter of university, getting jobs, hopefully, lined up. Hopefully offers that I can land and actually stick with. And I got, I think it's week 4 of my last quarter, so I got 6 weeks left, a month and a half, and I'm free. It's kind of wild to think. Especially after 4 years of university. It's wild. Alright, let's see what we got here. Alright. I hate this question. I hate Wolves of Wall Street so much. Okay, given a list of integers prices representing the stock price of a company in chronological order, return the maximum profit you could have made from buying and selling that stock any number of times. You must buy before you can sell, but you are not required to buy or sell the stock. This question I hate because it has given me so much. Your own boy, yeah. It's weird to think that the transition from student life to more kind of adult, you know, working constantly, sort of being self-responsible, is coming so soon. This question, from what I remember, you solve it right to left. It's definitely a greedy problem. You want to, I think, check if the price of I minus 1 is less than I. You want to buy I minus 1, sell I, and then I minus equals 2, I think. But Wolf of Wall Street should not be an easy question, if I'm being completely honest, because the difficulty of this question comes in sort of the edge cases, from what I remember. Buy at 1, sell at 5. Buy at 3 and sell at 6. I guess, because I mean we can't really. Yeah, so see, my idea there wouldn't give you maximum profit as is. Okay, let's see what else we have. Equivalent pairs. You're given a list of integers nums. Return the number of pairs I less than j such that nums at I equals nums at j. Do they have to be distinct pairs? Because we have 3, then that's 1 pair. That's one pair right there. That's 2 pairs, 3 pairs, and 4 pairs. So keep a hash set. We keep a hash map for this question. Hash map. If contains, we add map.get I to count, add current to map. I can actually just solve this one right away, I think. So let's do that. We got a hash map integers. Integer, map equals new hash map. Cool. I think the thing that makes Microsoft potentially more difficult than Google is that Microsoft actually has an IDE, and Google has just like a notepad. So Google's interview is a lot more focused on purely kind of your algorithmic thought process, while Microsoft's is focused on syntax and like very, making sure it runs and gives the correct output. Which I mean is in a sense what you're doing on the job, but it's a bit more difficult because you have to properly focus on syntax instead of just solving the problem kind of not with pseudocode, but with like pseudo-ish code. Alright, so if map.contains key, nums at I, what we're going to do is to say keep track of a count variable. This needs to be here. Make sure we keep track of our parentheses. Cool. So we're going to add that count to it. Count plus equals map dot get I. There we go. Then we're going to do is say map dot put nums at I. Map dot get or default. Great method. Every language should have something along these lines. Because otherwise, if you just try and get it without get or default and it's not present, it'll just throw you an exception. Nums at I, 0. Granted, it'd be better if it just didn't throw an exception, but who am I to say anything? I'm trying to count. There you go. Okay, it doesn't compile. What are we doing? The return value of java.util.hash.get is null. Which line? 14. Oh, nums at I. There we go. Perfect. There we go. Easy, done, submitted. Fairly straightforward question and a great example of why hash maps are one of the more useful data structures. Level order BST to linked list. Given a binary tree, convert it to a singly linked list using a level order traverse. I choked on my water. Okay, this question itself will not be very difficult. What we're going to do is pretty much a level order traversal works off of the idea of utilizing a queue, which is a first in last out data structure, to traverse a tree. So here we're looking to do, we're going to go to 1, then we're going to go to 2, then 3, then we're going to go to 4 and 5. So what we're going to do is make a queue of trees. Queue tree, queue equals new linked list of type trees. Cool. So we're also going to first of all say if root equals node. Okay, we don't need to do a null check because the constraints give us the fact that we are going to have at least one node here. So we're going to add the root node to the actual queue. Queue.add root. And then we're going to first of all do a linked list node head equals new linked list node. We're not going to give a value. Then we're going to do ll node is equal to head. This will allow us to keep a pointer to the head of this list for us to return after. Then we say while queue is not empty, we are going to take the top, convert front to a linked list node, add all its children to the queue. And level order is going to be left and then right. So what we're going to say is node.next equals new linked list node of, let's first of all pull from the queue, tree cur equals queue.pull. We're going to grab from the queue is going to be cur.val to grab the value from that tree, and then we're going to say node equals node.next. And then we need to actually add, let's go ahead and move this comment down to where it's appropriate. We're going to convert that to a linked list node, and we're going to add all the children. Hey, it's been going pretty good. I took a bit of a break over the weekend. I did some really basic questions Friday. Did one or two questions specific to Microsoft on Saturday, took Sunday off, was way too busy on Monday to really practice, and then here we are here. So it's been going pretty well. Yeah, it's definitely nice mentally, because it allows me to sort of refresh and come back with a new sort of mind space. Let's do if root.left is not equal null, q.add root.left. And we're going to do the same thing for root.right. How about yourself? How have your interview prep been going? There we go, root.right. There we go. I wonder if there's a way to do a recursive level order. There has to be. Turn head.next. Sweet. Ooh, we might, TLE, okay. Finally got a new grad offer at a cybersecurity company. I'm pretty stoked, exhausted from leak coding. Congrats, man. Well deserved. Yeah, it takes a lot of work to get there, but once you finally actually land that offer, it's very, very worthwhile. Congrats. How's it feel to have that sort of job security? Okay, where are we going wrong? Node. Wait, no, it's cur. There we go. We're gonna keep continually adding the wrong nodes to the queue. Compilation error, that's better. Perfect. And let's submit. Bada bing, bada boom, problem solved. Interesting that plain BFS and notice nodes fall in the same way as native construct nodes along the way. Weird. Okay, how'd you do a BFS? I mean, BFS is done using a queue, so I guess in a way I did do a BFS. Actually, I did do a BFS. Like, technically a BFS of this is just a level order traversal, which is really cool. Okay, let's see what we got. You are given a list of integers nums where each integer occurs exactly 3 times, except for one which occurs once. Bonus, can you solve it in O of 1 space? Okay, I guess the way to do it without O of 1 space, so once you get the offer, it's such a sigh of relief. I'm pretty satisfied with the job offer, so I stopped leak coding. The job involves building cloud security apps on cloud service, so for now I'll be learning through side projects. Dude, that sounds like you not only landed a job, it sounds like you landed a really fun job. AWS, Azure, GCP. Dude, you landed jobs utilizing technology that I think all of us want to learn. And what's great is on your resume now, you'll be able to slap all those keywords on and get automatically picked up by every automated resume screening software. Congrats, it's well deserved. Okay, in O of 1, just sort it. Sort the array, keep count, easy. Yeah, I mean, that's gotta be the way to do it. Unless this is too slow. I is less than num cell length. I plus plus. I have a feeling you'll be getting offers soon, keep it up. Yeah, no, I mean, I've had 3 job offers at this point, but because of how timing worked out, my first 2, I'm obviously not complaining, getting any job offer is awesome, but I had 2 that I was deciding between. I got a 3rd offer it was given to me on the day that I had to decide for my other 2 offers, so I rejected the other 2 because the pay for this one was a lot better. Where'd they go? They were decent. I mean, to put into perspective, both had a base salary of $80,000, which it's by no means a little amount of money. But the other one offered me, to not lie, I think it was like 130,000 base. So I obviously dropped the other 2 to get this one, and then there were some complications along the way. Didn't work out, separated on good terms. So I lost all 3 offers because of that. So I'm back here kind of banking on landing Microsoft. Yeah, it was not a fun situation to be in, but hey, you know, gotta keep your head up, gotta keep going. Equals 1. Okay, the length -1. So we gotta just keep track of where we are in this array. So if, let's do this. Int cur equals nums at 0. What's our restriction here? Yeah, nums can be 0. We'll handle that edge case later on. Cur count is going to be equal to 1. So we're going to start this off at 1. Google did not contact me again. I know they're slow generally, and especially with they're having pausing head counts and doing whatever. So it's good. I'm expecting about another 2-3 weeks before I hear back from them. Yeah, we're in a career that has a lot of demand. Somehow the demand isn't for me, but we'll get there. We'll get there. If nums at I is equal to cur count plus plus. Else, if cur count is equal to 1, return nums at I. Cur count equals 1. Cur equals nums at I. This should allow us to, in I think it's O of 1 space and log n time, we're going to return -1 here because we should never really be hitting this return. Cool. Wrong answer, -1. Cur count is less than or equal to 3. Strange. Okay. Let's print out checking. Plus nums at I. And this should allow us to really see what we're working with and when. And this music is so nice. Swapping. Okay, let's see. Checking 2. So 2, 2. I can kind of see the issue we're having here, but oh, it's gonna be that. Still a -1, huh? Okay, I guess if cur count is equal to 1, return the integer that doesn't occur 3 times will only appear once. Yeah, that's what I'm trying to sort of wrap my head around. I think I just need to do this here. Nums at nums.length -1. I'm just trying to stave off having to do Wolf of Wall Street. Yeah. Alright, we got... So 0, we... Strange that we don't actually end up checking 0 ever. So... return cur. There we go. It's got a TLE probably because of these. Yeah. Is there a nums.count x built-in method in Java? Python, unsure about Java. I don't think that it does. It seems like a very Python-esque sort of method. But yeah, this is gonna work. Very slow. Interesting, okay. All the numbers repeat. One's at each bit. Okay, this has a very, I'm curious what the top bit manip, okay. It's O of n, but unsure how they want O of 1 time. Yeah, so this is n log n time and space, but yeah, bit manipulation by far is one of my sort of, it's not necessarily my weakest subject, but it's the one that I have not really practiced because it doesn't appear to practically show up anywhere. Really? So I don't even know. It's very, there's specific rules that you can apply because bit manipulation works in binary. For example, if you do like x equals 2 and then you shift x to the right by 1, it's divided by 2, so x then becomes 1. But if you shift x to the left by 2, or by 1 rather, it multiplies by 2. So x just becomes 4. Because if you think about the binary representation, you're just shifting every bit up 1 power of 2. So 2 becomes 4, 4 becomes, I don't know. I can't do powers of 2 in my head at the moment. Okay, let's try and tackle the really difficult question out of all of these. Is freaking Wolf of Wall Street. Okay. So we can go here, go up until the price begins to increase, sell off, buy next. Yeah, no, dude, bit manipulation, it's very, very useful because it in certain situations allows for very fast arithmetic, but because you're not like doing any actual calculation, you're just shifting a binary number over by 1 in either direction. And doing logical, I think you have your bitwise and bitwise OR, XOR has its own thing. You have to sort of be very confident in your knowledge of binary representations of things. Okay, so let's do for int I equals prices dot length minus 1, I is greater than or equal to 0, I plus plus. Okay, so conditions that we have to do here, right? Let's keep track of profit. 0. Int current int bot price. Int cur boolean bot equals false. There we go. So how do we make use of this information is the real question. So I think what we should do is always purchase the stock. So we take a sell price. This should not be a difficult question. It's labeled as easy. So, let's say we start at the end, right? If we haven't bought the stock yet, then we can set the current buy to buy at this, or yeah, so we can set the sell to be this current one. sell price equals 0. Fan in the background? Yeah, I'm not sure how much I can... Yeah, it's my laptop not liking how fast, how much it has to run here. Let me see if I can turn it into quiet mode. Because I am running this whole thing off of... Let's do silent. Keep my... That should hopefully quiet it down a bit. Yeah, no, I don't have like a proper mic setup or anything. I'm just using my webcam. Okay, so... so sell price is equal to num set I. And now we can set... Oh, okay, perfect. Yeah, it's calmed the fan down a bit. It's a pretty beefy laptop, so it likes to spool up a lot. So we're gonna set bot equals to true. Then, if we've ever purchased anything, we're going to look for the next else. We're going to look for whatever our best option for actually like purchasing the stock. So what we're gonna say is if nums at I is greater, oh geez, if nums at I is greater than sell price, basically if there's a better option to sell this stock, we're going to update that nums at I. Cool. What now? This should allow us to find the optimal sell price. Otherwise, okay, couple things, right? If this is the first element in the array, we know we have to sell. To sell if we can. Cool. I'm gonna take a bit of a break here, step out, and then come back to finish this one. You know, I was wondering why my my laptop was spooling up. Hey, NT Maxter, yeah. Okay, thanks for the follow. Yeah, I was wondering why it's spooling up. Then I realized that like I'm running an entire streaming sort of setup off of it, alongside some other things, and I'm impressed it's staying as quiet as it is, to be honest. We have to sell if we can. So if I equals 0. Yep, thank you, man. Appreciate it. Okay, so if I is equal to 0. Profit plus equals sell price minus nums at 0. Cool. This will allow us to auto sell. Then otherwise, if nums at I minus 1 is greater than nums at I, we found the cheapest buy. So now we sell. profit is plus equals sell price minus nums at I. So I think that should work. And in this case, if we sold it, we need to say bought equals false to make sure that we can resell it. Somewhere here outside the loop, we return profit. Run. Perfect. Compile. Perfect. I was expecting that. Sell price equals prices at I, not nums. Oh, I have to change all of these now. So used to the array being called nums. I've done that in interviews where like they'll call their like trees something else, or they'll call their link nodes something else, and I'll just default to the binary search ones. Prices. So many prices. Okay, I think that's gonna be, yeah, there's no way that works. On line 19, helps to decrement I instead. Perfect. Somehow that works. No way! First try! I did not expect that. Did not expect to actually... Jeez, okay. I guess the only thing to do from here is that there are, still 20 minutes left. I'm gonna pop open LeetCode, gonna find some Microsoft problems, and I guess go through and solve them on Microsoft's and for LeetCode. Get some more practice in that way. But I genuinely was not expecting to solve Wolf of Wall Street that easily. Because I remember this problem giving me so much headache. Let's do problems. Pop this tab back in. Okay. I deliberately didn't label this stream as binary search because I am going all over the place here. Microsoft. And we're going to, once this hopefully loads, oh, they're hiring. Maybe I should apply to LeetCode. I wonder if they're gonna use, they probably will use LeetCode as their interview thing, huh? Alright, to-sum, add two numbers, longest string without repeating characters. I'm just going to go off the assumption that I won't be seeing any hard questions. And, let's see, reverse words in a string. Minimum deletions to make character frequencies unique. I guess let's do longest happy string and see what this one's about. A string is called happy if it satisfies the following conditions. Only contains the letters A, B, C. Does not contain any of AAA, BBB, or CCC as substring. Contains at most A occurrences of A, B occurrences of B, C occurrences of C. Given three integers A, B, C, return the longest possible happy string. If there are multiple happy strings, return any of them. If there's no such string, is this dynamic programming? Really? String and greedy. Okay, no DP. If it's not DP, then I'm willing to try it, but I've just been avoiding it like wildfire, and I'm going to continue to do so, and if I get a DP problem, I'm going to solve it in n squared unoptimized and be good. Okay. So happy strings. First things first, right? We're going to obviously need maybe a hash map here. Longest possible happy string. Trying to think if I'm trying to think if there's any point where, for example, starting, I don't think, so if this was a happy string and let's say we stopped here, we know that starting here would make a less long happy string. So first things first, we do not need to do n squared starting from every block, every character. Then, so we can start this for loop. 0 I. Wait. Yep. Take care, man. Take care. Thank you for stopping by. Okay. Oh, wait a minute. So, wait. Okay, hold on. Oh, we're supposed to build out the happy string. Okay. Not actually do anything with it. I guess we. How do you actually do this? I guess we need to okay, let's just kind of do some brainstorming. So we can't have a character appear more than 3 times. More than. Okay, can't appear more than 2 times in a row. So I guess we want to take the one that we have the most of. Most, maybe least, most, least. So most we do. I actually have no real clue how to tackle this one, if I'm being honest. So looks like we need to take the one we have most of, add 2, then take one we have least of, add 1, and rinse and repeat, basically. That seems like the way to approach this one. Very interested about, what's it called? About the fact that it's labeled as a priority queue question. Because I don't think we can really. How do we actually tackle this question? What does a priority queue provide here for us? A priority queue provides us with a way to order our things, right? Which will always give us the one that we have the least of, unless we make it a max heap, I think it is. So yeah, for example, here we would take AA, we'd find C as being the least. If C is equal to, we're not even going to add C if it's equal to 0. Find the, take the least that is greater than 0, and add 1 of that one. I guess we can try and implement this. I guess let's try and implement this just using a hash map. I can see the greedy aspect of it coming through, but that doesn't really explain how this is a priority queue question. So let's do string results equals an empty string. So let's do hash map of integer or character integer equals new hash map. Cool, so we're gonna do map.put a, let's just make it a string. We're gonna put A. Let's go ahead and first of all right away do if A greater than 0, because we don't even want to put we don't want to put the 0-based ones in for no reason. There's no point to doing it. Not greater than or equal to 0, just greater than 0. And we're gonna then add A to our hash map. So we're going to do that, and we're going to do the same thing for the other ones. This is why I like my hash maps, just because, you know, if you don't know how to approach a question, more often than not, you can just chuck a hash map at it, and you'll get somewhere. So, first things first, find the max element we can add. Let's also do boolean is valid. Ah, man. Jeez, okay, yeah, I don't actually know how to... I guess, so is valid. True. While is valid. Okay. So here's what we're gonna do. We're gonna first find max element to add. So string max equals empty string max int max occur to be equal to 0 for in string s in map.keyset. We're going to look at all the keys. I guess we should also have car string previous equals. This could be very slow because strings make new objects each time, and we don't really want to do that. I can change that to a character later on. If map.get s is greater than max occur, and it's not the previous character, because we can't have more than 2 in a row. And s not s dot equals previous. And go ahead and set max equal to s max occur map dot get s. Perfect. So this should allow us to, at any point, find the element to add that's the most, and then add 2 of the element to the map if we can. If max occur greater than 2, we're going to add only 2. So result equals result plus max. And we're going to do map.put map.get map.get max map.put wait, hold on, max map.get max, and we're going to subtract 2 from that count. Pretty much remove the 2 of the character. Hey, good to see you, man. That should do that, and then we're gonna update. Otherwise, we're going to, what are we going to do? We're going to for int I equals 0, I is less than max occur, I plus plus, result equals result plus max. And because it's less than 2, we know we're going to need to remove it from the map. Then we need to update the current. Previous equals max. And we're going to do the same sort of logic to find the minimum, right? What did I just do? Ooh, I think I just refreshed my graphics driver somehow. Yeah, we still got 5 minutes in this one. 2, 3. Okay. How do we, so let's do find min. You know, feeling kind of brain dead with this question. I want to look at, there's no real solution available. I want to see, okay, I'm trying to figure out, wait, you can do that? You can do that? I genuinely had no idea you could utilize kind of data structures that you're working with in the Lambda expression declaration, because this is exactly what I was trying to do here. You sort whichever one is the highest count, and this allows you to do that using that hash map. And then if they're greater than 0, yep, you add there. String for string builder, okay, and then this is kind of where they diverge slightly. Car first, car second. SB, what's SB? SB, yep, so we're gonna append first and second. If map.get first, subtract 1, dot get second is greater than 1. You subtract it and you add it back in. If the priority queue size is equal to return 0, okay, that makes sense. So sb.append rem. Okay, so that's the remaining character, and then we want to add the remainder. Builder solution. This is where it kind of lost me, but it's a very clever solution. Okay, let's assume that no similar character can be next to each other. Form a string with greedy approach, breaking the top 2 by frequency and appending. Do this only until only 1 element is remaining. Then take this element and double it wherever it's already present in the string. Ooh, that's smart. So that's what this is doing. We find whatever the remaining element is, and if we ever find it and there's more left of it, we want to double it up because man, that's clever. Gonna post that. It's very good. Great. Okay. And I just want to see how fast it runs comparatively to other ones. That is a very good thing to know. I can see where the priority queue would come in now. All right. Sweet. Pretty quick solution as well. All right. Okay. Join back into the room. Alright, we got 1 minute left. After 1 minute, I'll go over my solutions, and then we can go from there. Okay, I guess I can start going over them now. So, starting off with the first question that I solved, which was equivalent pairs. What I wanted to do is pretty much iterate through the array an O of n time, and because any item, let's say here, can be paired with, let's say, this item, and this item, and this item could also be paired with this item. So what I did was pretty much iterate through and add the count of every given element into a map. And then, every time I encountered that element, I added however many the map had in it to the overall total, because that is the total number of pairs that it can be, the numbers that it can make pairs with. For example, this 2 here can make a pair with this 2, this 3 can make a pair with this 3, this 2 can make a pair with this 2 and this 2. And I just kept doing that, and then I just returned the total count, which provides a relatively fast solution. Yeah. I'm not sure if there's faster ways to do it or if binary search is just being slow today, but this is running an O of n time with O of n space for this map to store every element in the array. Question 3, level order binary tree to linked list. My initial thought was quite literally to just do a level order traversal, which I did, and every time I found a node from the queue, I'd just make it a linked list node and then add it to the end of a linked list, and this allowed me to convert the binary tree into a linked list. Looking through the hints after, it told me that a BFS was appropriate, and looking at this, if you really think about it, BFS is just iterate through graph using a queue. And that's, in a sense, what I did. If you treat this as a directional graph, and this as your starting node, I pretty much did a BFS because I would go here, then I would explore here, there's nothing to explore, then I would explore 4 and 5 and so on. This is running in, it's very hard to, I think, graphs, I think this is just O of n time. I think I'm going to consider it O of n space, because we do need to make a new linked list node for every node in our binary tree, but that might be just O of 1 if it's considered something that's expected. Number 4, this one apparently was supposed to be done using like bit manipulation, but being completely honest with you, I did not have a clue about how to do this with bit manipulation. So instead what I did was I did a more greedy approach, still O of 1 space like they were asking for, but I sorted the list and I pretty much kept track of counts of numbers, and anytime I would find a different number, basically if it'll either occur 3 times or 1 time. So pretty much any time I would encounter a number that was different, if that number had occurred up to this point less than 3 times, which could only be 1, it means it was the odd one out. And I had to make sure to add this sort of fence post condition. Fence post problems are something you will learn about in your very first CS class, and they show up a lot more often than you'd really expect, because in the case that, let's say, even for this one, after sorting the 9 goes to the end, we would never hit this condition with this check, because 9 would just be here, so we have to check for it out here. This does run an n log n time with O of 1 space like it was asking, so it's still a pretty good solution. Then comes my nemesis, freaking Wolf of Wall Street. I've solved this question individually probably like 4 or 5 times over the course of my entire sort of binary search time. But every time I see it, it still makes me shudder, because the first time, I kid you not, I probably spent like an hour and a half on it, and I could not get it down. So the difficult part of this is coming up with an approach that works, and an approach that, I guess just that, like coming up with the logic of the steps to take is the difficult part. So what I do is I keep track of our total profit, obviously. I keep track of the best sell price we've seen, and whether we have purchased a stock or not. And the reason that I iterate backwards through the array is because I always just want to know how much I can sell it for before purchasing it. Because purchasing it and then finding the best sell price makes this problem a bit more challenging, at least for me to visualize. So I'd go through, if I hadn't purchased the stock, I'd automatically just set it to purchase this stock that we're looking at. Then, what I do is basically check, are we at the very, very beginning? If we're at the very beginning and we've purchased the stock, which would only be in this conditional if we'd purchased the stock up to that point, then we need to sell it and take whatever profit we can get and just run with it. Otherwise, we have to do a couple checks. Actually, this one, my bad. Pretty much saying if the price that we're currently looking at is higher than whatever we've seen as the highest sell price up to this point, we need to grab this sell price. For example, if this was an 8, this 8 would be a better sell-off point than this 6. So we need to grab that 8 as our next sell-off point. Otherwise, if we're at the very, very beginning, this is where we auto-sell if we've purchased anything to make sure that we squeeze out that last little bit of profit. Otherwise, if we see that the price that comes before this element is greater than the one here, for example, this 5, we know that we'd be losing money by not selling at this 3. So what we do is we just sell at the 3, and we set bot to false. And doing so at every step allows us to sort of, I'd say greedily, because we just take the best sell price we can get here. Doing this allows us to, in a greedy sort of way, always sell off for the best profit and always find our highest margins. This runs in O of n time with O of 1 space, which is a pretty good solution, although I'm not quite sure what the faster approach to this is. But yeah, that's pretty much that. Longest happy string, very actually clever question. Like, I genuinely kind of enjoyed learning about this one, especially this right here. This is very, very good to know, and I'll definitely be using that later. The greedy part of it was very, very interesting to me, because I mean, you always just do it by ones until you've only got one left, and then you just do the remainder. Really cool problem. Okay, that's gonna be it for me today. I'm gonna go have breakfast. It's getting quite late for that, so thank you everyone for stopping by. I'll be on tomorrow. Not sure, I think for maybe a bit longer than today, just because it is the day before the interview and I want to make sure that I'm as fresh as can be. Yeah, appreciate it. All right, take care everyone. Best of luck in all of your interviews, and I will see you tomorrow.